Now we're going to turn our attention to a different classification system. We started off thinking about a product-based classification. That was the distinction between materials, labor, and overhead. And of course, in activity-based costing, we expanded the different types of overhead into different activity pools. An alternative view is often needed because many decisions require making predictions about what costs will be. In other words, we're making decisions where we don't know what the future holds necessarily. We want to make the best decision possible, so we want to predict as best as possible what we were likely to see. So a common question to ask is, under different circumstances, with different decisions, how will costs behave? Now, when we think about cost behavior, there's a first step that we need to identify, and that is the activity of interest. In many situations, we might consider that to be production volume. What will our production volume be during a given time period? Higher or lower? That would be the activity of interest. But it doesn't necessarily have to be production. It could also be something about the inputs, and that might be how much our labor is working, perhaps measured by labor hours. And of course, other activities of interest arise in different organizations. Maybe this is the number of customer visits or service calls. Whatever your activity of interest is, we would then classify our costs according to the behavior that correlated with this activity of interest. And so we have three general categories of cost behavior. Costs can be variable, fixed, or mixed in some fashion. So let's turn to variable costs. And if I was going to depict this graphically, what I see on the horizontal axis is the identified activity of interest. Keeping it simple, we'll look at production volume. On the left-hand side, we have lower levels of production volume, and on the right-hand side, we would have higher volume of production. The vertical axis is represented in terms of cost. Low levels of cost down below. As we progress up the y-axis, it's higher levels of cost. So now, if I was going to graph the relationship between production volume and costs that would be classified as variable, what would this line really look like? If these costs were purely variable, I would draw a line that was upward sloping, meaning that at lower levels of production volume, variable costs would be lower, and at higher levels of production volume, variable costs would be higher. Now, examples of variable costs would be things that we've talked about before, direct materials and direct labor, meaning that we would incur higher levels of material costs and labor costs as we produced more. This is because these costs will be correlated with our activity of interest, the production volume. Overhead costs that also can be variable in nature include electricity, water, and other utilities. Not necessarily perfectly correlated because those costs are indirect with respect to the different units, but on average, electricity costs would be higher the more that we produce. So I would classify some types of overhead, like electricity, in the variable cost category. Now, how about fixed costs? Again, we have the same schematic, from low levels to high levels of production volume on the horizontal axis, and from low levels to high levels of cost on the vertical axis. And again, thinking about the relationship between production volume and total fixed costs, what would this line look like? Well, if I had to answer, it would be a horizontal line across the middle of the graph. Because costs that are fixed don't change with production volume, you can see that the level of cost doesn't fluctuate with production volume, meaning it's not upward sloping or downward sloping. It's just level over those various levels of production volume. Examples of fixed costs would be things like rent for the factory or facility that I have, or perhaps salaries for managers that get paid not on an hourly basis or per unit basis, but just over a month or a year. These costs are fixed with respect to production volume in this example, meaning that they don't fluctuate with the volume. Very different than variable costs. Now, one more category would be something in between the two, something generically referred to as mixed costs. These costs have both variable and fixed components. Now, there would be a lot of different ways that you could draw this curve or this graph, but let's keep it simple and draw an upward sloping line that intersects the y-axis or the vertical axis at a non-zero point. That distance between the origin, or where the two axes meet, and where the line crosses the vertical axis would be the amount of fixed costs. And then, as production volume increases, so does the variable component of these mixed costs. So costs go up and up the more production volume we produce. Non-zero even at low levels because of the fixed component, and an upward sloping line because of the variable component. Now, examples that I can think of when I think about mixed costs, that would be kind of like your mobile phone bill. There's always a fee each month just to connect to the service, but then as you use more and more minutes, your cost goes up and up. Other forms of compensation, like a base pay but plus some bonus, would be an example of a mixed cost. No matter what, we're paying our employees a certain amount per week or per month, but the more that they produce, the more that they earn on top of that base pay. That would be another example of mixed costs. Now, one caveat in this is that I've drawn these lines in a very simple manner. Take, for instance, the total variable costs. Originally, we had a straight line originating from the origin and then sloping upward, and that line was depicted as linear. In reality, that line isn't necessarily all that straight. We might have, for a while, a certain amount of variable cost per unit, but then as you reach higher levels of production volume, that variable cost per unit changes in some way. Perhaps we earn economies of scale or scope, and what that means is that it gets cheaper the more that we produce. So you might see that the line that captures total variable costs is not perfectly straight, that it changes in the rate of slope over different levels of production volume. The same could be said about fixed costs. We depicted that graph as a flat line over the range of production volume. Things like rent, where that doesn't change no matter how much you produce. Well, that's not necessarily true. We might increase our production volume to the point that we are at or over capacity of the facility we currently rent. And in order for us to reach higher levels of production volume, we would need an additional facility. We would need to increase our capacity. And what we would signal there is that the fixed costs would jump or step up to the next level in order to reach those higher levels of production volume. So in many cases, we'll just assume away some of these intricacies. We'll assume that we're working within a particular relevant range or range of production volume for which the variable costs and fixed costs behave consistently across those volumes. But we'll always take into account that some of those costs can change at different points in the production volume range. Now let's have a checkpoint to exercise this knowledge in a more applied fashion.